It's the correct version of the word extremes. Correct. People will say extremes. What are extremes? The maximum or the minimum. So what we're going to be looking at in Chapter 3 in Section 3.1 is minimums and maximums. I don't think we'll plug 0 into the derivative. So I'm going to draw a function here. Kind of a weird function. I don't know what the equation is. I just drew a picture. But I want you to notice some things. This point right here would have a special name. What would you call that point right there? That's the absolute maximum. How come?
Because it's the highest point on the graph.
It's the absolute highest point on the graph. This point right here we would call absolute maximum. As opposed to this point right here and that point right there. What would we call those 2 points?
Relative.
Those are called relative maximums, also called local maximums. They are, like this point right here, this is the highest point for everything close to it. So it's the highest point for everything relatively close. That's why people call it relative maximum. Or they call it local maximums. It's the highest point in its local area. So those 2 points are called local or relative maximums. And by the same token, we have this point and that point, and those would be called relative or local minimums. Put relative wrong. And we would say that this graph does not have an absolute minimum. How come this graph does not have an absolute minimum? It goes down forever, and it does that on each side. So there's no lowest point. The graph keeps going down. All right. Now, interesting things are happening at these maximum and these minimums. Let's deal with this minimum first. At this relative minimum right here, we have a sharp corner. What can you tell me about the derivative when you have a sharp corner like that? The derivative does not exist. So at this point right here, f prime of x is undefined. And how about the absolute maximum and all the other relatives? What can you tell me about the derivative there? It should be 0. Think about tangent lines. If I'm drawing tangent lines, over here, my derivative would be positive, wouldn't it be? But what happens right when I get to that maximum? My tangent line becomes 0. The slope becomes 0. And then when I go past that, the derivative becomes negative. And the same thing happens here. If I were to look at this local minimum, my derivative, my tangent lines would have negative slope until I get right to that point, and then my slope would be 0. So at all these other points, f prime of x is 0. So, that's a simple fact about graphs. A function, f of x, will have all of its mins and maxes when f prime of x equals 0 or f prime of x is undefined.
So is that graph have all of these?
Right, so this graph has 2 minimums. It's got one there and one there. It happens to not have a local an absolute minimum. That's okay. It's okay if it doesn't have an absolute minimum.
So if there's a minimum, there's a maximum.
Right, if there is a minimum or a maximum, then either the derivative is 0 or the derivative is undefined. The minimum might be a local minimum, it might be an absolute minimum. You don't know yet. We will develop tests for telling when we have locals, when we have absolutes. All right, so the spots where the derivative is 0 or the derivative is undefined are very important. So they have a special name. Anybody know the special name for a place where the derivative is 0 or the derivative is undefined? These are called critical points. The points where f prime of c equals 0 or f prime of c is undefined and f of c is defined are called critical points. All right, I have some problems out of the book here. Find the right page. Where is it? 3.1. Here we go. F of x equals x to the fourth minus 8x squared. Find the critical points. What do? The right answer is almost always take the derivative. So we take the derivative. F prime of x is 4x cubed minus 16x. Almost wrote 16x squared there. Then, to find the critical points, we take the derivative and we set it equal to 0. 4x cubed minus 16x equals 0. How do you solve that equation? Factor out of 4x, so 4x times x squared minus 4 equals 0. Factor some more. X squared minus 4 factors as x plus 2x minus 2. And so we would have x is x is 0 would be one of them, correct? Because of the 4x. X would be negative 2. X would be positive 2. Okay, those are called the critical numbers, but I actually asked you to find the critical points. What's the difference between a critical number and a critical point? To get the point, I have to plug it back in. I have to have an x number and a y number. When you say plug it back in, where am I plugging 0 into? Into the original equation. The original equation gives you y numbers. What does the f prime equation give you? Slopes. Correct. So if I want the y numbers, I got to plug back into the original. So if x is 0, y is 0. If x is negative 2, y is something. Negative 2 to the fourth. 16. Negative 2 squared. 4. 8 times 4. 32. 16 minus 32. Negative 16. And if x is 2, also negative 16. So there would be my 3 critical points. Just for fun, let's draw a graph of that function. X to the fourth didn't show up any better. Sometimes it shows up better when I angle it. X to the fourth minus 8x squared. Oh, I got a bad window. Window. I want to go from negative 10 to 10 and negative 20 to 20. And you can see what's happening. What's happening at negative 2, negative 16? There's a minimum. And what's happening at 2 comma negative 16? Also a minimum. In fact, in this case, we have 2 absolute minimums, which is kind of weird. But we would accept that there are 2 absolute minimums because they're both at the same lowest value. And at 0, 0, we have a local maximum. Correct. Okay, graph looks like that.
Isn't the rule that there should be one less than a power number of critical points?
Correct. If your original polynomial has degree 4, then there should be 3 critical points. The problem you might run into is you might get 3 real numbers. You might get 1 real number and 2 complex numbers. And in this class, we don't deal with the complex numbers. So it's possible that a 4th degree polynomial would only have 1 critical point. That can happen. What would it look like? It would look like y equals x to the 4th. Because if I take the derivative of y equals x to the 4th, what do I get? 4x cubed. X is 0 is the only number that works, right? So what would it look like? It looks a lot like x squared, but it's not really quite x squared. So in this case, you just have a minimum. There's no maximum points on that one.
Do we ever have to do imaginary numbers?
In this class, we will never do imaginary numbers.
That was one of pairs.
They always come in pairs. That's correct. That's called the conjugate pairs theorem. All right, let's try another one here. Oh, let's see. There's got to be a harder one. Oh, there's a harder one. Yay! G of x is 4x over x squared plus 1. Why is that one harder? Quotient rule. G prime of x is x squared plus 1. That's the bottom. Times the derivative of the top, which is 4. Minus the top, that's 4x. Times the derivative of the bottom, which is 2x. All over bottom squared. Do you remember, not so long ago, I told you you don't have to simplify derivatives.
No,
Guess what? Now you have to simplify derivatives. Because what do we need to do with that derivative?
after it.
Well, we need to set it equal to 0 in order to solve the equation. The only way to solve the equation is to simplify it. So at this point in your life, you do have to start simplifying derivatives. All right, so I would take, distribute the 4 through. That's going to be 4x squared plus 4 minus 8x squared over x squared plus 1 squared. And what I really need to do is I need to set that equal to 0. Good news is this one's not too hard to simplify. See if we can find a harder one. 4 minus 4x squared over x squared plus 1 squared equals 0. Now, how can a fraction equal the number 0? Only the top can be 0. How come? If the bottom is 0, it's undefined. But we also need to know that. Very good. And this is something that a lot of students will forget. A critical point happens when the derivative is 0 or when the derivative is undefined.
So just take the top side and equal to 0 and then take the bottom side.
Correct. So what you need to do anytime you have a fraction is you need to take the top, set it equal to 0, and you need to take the bottom and set it equal to 0. You need to worry about both where it is 0, which is when the top is 0, and when it's undefined, which is when the bottom is 0. So we need to solve 4 minus 4x squared equals 0. And we need to solve x squared plus 1 squared equals 0. We need to solve them both. How do you solve the first one? I can factor a 4 out, and I'm left with 1 minus x squared. And 1 minus x squared factors as 1 minus x, 1 plus x. X is 1, x is negative 1. Okay, that one's done. How about the next equation? X is also plus or minus 1? I disagree. Because if I plug 1 in, 1 squared plus 1 is 2. I don't get 0. First thing I do is I take the square root of both sides. That gets rid of that square on the outside.
Then subtract 1.
Subtract 1. When does x squared equal negative 1? Never in this class. Because we do not do imaginary numbers. So it's nothing from that equation. And that's going to happen sometimes. That's okay. All right. So finally, we would go back to our original equation. When x is 1, y is going to be 2. And when x is negative 1, y is going to be negative 2. Questions on that? All right, the last thing we have in this section is something called the extreme value theorem. It says if f of x is continuous on some closed interval a to b, then f of x will have an absolute min and absolute max on the interval. There's more. Moreover, the min and max will occur at x equals a, x equals b, or some critical point between a and b. Critical number, I guess I will say. All right, so first off, you need to remind me, what do we mean by a function is continuous? No jumps, no breaks, no gaps. You can essentially draw the graph without lifting your pen. Can't read my writing? Where are you stuck? You got it? Okay. If I give you an equation, how will you know if the equation is continuous without having to draw a graph and do a lot of work? What sort of things do you look out for? Yeah, the 3 rules, that's true. I don't really want to go through all 3 rules, though. Division by 0 is the big thing to watch out for. So if you have division by 0, you're not going to be continuous. All right, so let me give you an example. Show you how these problems work. Oh, let's see. Let's start with a fairly easy one. F of x equals x cubed minus 3 halves x squared. And my interval is negative 1 to 2. Is that function continuous on the interval negative 1 to 2? Yes, your answer is yes, because it's a special kind of function. It's begins with a P, polynomial. It's a polynomial function. And where are polynomial functions continuous? Everywhere. Polynomial functions are always continuous. So, I want you to find the absolute minimum and the absolute maximum on the interval negative 1 to 2. What do you do? Nope. The right answer is almost always take the derivative. The right answer is almost always take the derivative. You take the derivative. F prime of x is 3x squared minus 3x. And then what do you do with the derivative? You set it equal to 0 to find the critical numbers. I'm going to do 2 steps at once here. I'm going to factor the 3x out and set it equal to 0. So I get 2 critical numbers, x equals 0, x equals 1. Now what I do is I build myself a little table. I'm going to plug in 0, I'm going to plug in 1, I'm going to plug in -1, and I'm going to plug in 2. How come I plug in 0 and 1? Those are my critical numbers. They're critical. It seems like I want to plug them in. Why do I plug in -1 and 2? That's the end point of the intervals. All right, so I plug 0 in. I like it when I plug 0 in. I can do that in my head. I get 0. I plug in 1. I get 1 minus 3/2. 1 minus 3/2 is -1/2. I plug -1 in. I get -1 minus 3/2. -1 minus 3/2 is -5/2. And finally, I plug in 2. I get 8 minus 12, I think. Right? No. 8 minus 6. Right? Because 2 squared is 4. 4 divided by 2 is 2. 8 minus 6 is 2. So, where is my absolute maximum? 2, 2. There's the absolute max. How come? That's true. Oops. It's the biggest y number. The biggest y number is 2. So that's the maximum. Where's the absolute minimum? -1, -5/2. Because that's the smallest y value. That's the absolute minimum. Questions on that? That's it. H of x is x over x plus 3. And our interval is -1 to 6. Is h of x a continuous function? Correct. It is continuous in this interval, but not overall. Why is it not continuous overall? It's not continuous at -3, but -3 is not in our interval, so we don't care. So is this function continuous? Yes, it is in our interval. And that's all we really need for this problem. If the interval was -4 to 6, then your answer would be the function is not continuous. I can't use the theorem. The theorem says the function has to be continuous. All right, what do? I derive it. H prime of x is the bottom, x plus 3. Derivative of the top, 1. Minus the top, that's x. Derivative of the bottom, 1. Over x plus 3 squared. So that is 3 over x plus 3 squared. So when is the top equal to 0? It's a trick question. Never is correct. The top is the number 3. It's never equal to 0. When is the bottom equal to 0? When x is -3. We throw that out. How come? 2 correct answers. 1, -3 is not in our interval. And 2, -3 cannot be plugged into the original function. So would -3 be a critical number? No, because to be a critical number, you need to be able to plug it into the original function also. So -3 would not be a critical number no matter what our interval was, because it cannot go into the original function. So this time all you need to do is build a little table. What numbers are you going to plug in? Not 0. -1 and 6. You plug in your endpoints and you plug in your critical numbers, but we don't have any critical numbers. You just plug in your endpoints. I plug in -1, I get -1 over 2, that's -1/2. I plug in 6, I get 6 over 9, 2/3. Where's the absolute minimum? There's the absolute min. And how about the absolute max? Only other choice. There it is. Questions?